So today we're going over the notation of derivatives and the graph analysis of derivatives. So first we're going to go over the notation. Just like with limits, notation is super duper really important because the way we write the notation completely describes what we mean to say in mathematics. And if it's correct, then it's complete. I don't know how else to say that. Like, my mom went to the store. If I take out mom as my went to the store, it could be anything. It can be my dog went to the store. So you have to be careful if you do leave something out. So we don't want to leave anything out. We want to leave everything in there so it can completely describe the concept that we're going to be doing or what we understand about the concepts already. So here we go. You should be copying this down perhaps as I was talking already. If not, pause it, start copying. This one and this one is basically the same thing. F prime of x is where we're saying our first derivative, and y prime is the same thing. It's saying we have our first derivative. With y prime, it doesn't name the independent variable, okay, like it does with f prime of x. So that's what's neat about this notation, is because if the independent variable is t, maybe for time, we can see that there, but this would still just be y prime, and we don't see the independent variable. Okay. There's another way that we can write with y a derivative, and that is dy over dx, and that's what's written here. The derivative of y with respect to x. I have to say that these are pretty much the ones that we use if our function is f of x. Now, if there is a particular number that we're evaluating, okay, then we would plug in that number for x. So if we wanted the first derivative when x is 2, we just plug in the 2. Whereas over here, we don't want to plug it in for x. We would just use a parentheses thereafter, as you see here. Okay? Now the next one you're copying, we don't see all that often df over dx, but it is a notation that we can use. It's the derivative of f with respect to x. And it's basically saying, okay, the function we're working with. So sometimes instead of just the value that we want to plug in, we actually write out the function next to dy over dx. And then we put a line and we write when x is 2. Okay? Actually, a lot of times that's what you'll see me doing in our lessons. In any case, that leads to the same notation you see down here, okay, at the bottom. This is another expression. Okay, it emphasizes the idea that differentiation is on an operation performed on f. So just d over dx is saying that you're taking the derivative with respect to x, okay, which is a nice way of indicating what we're taking the derivative with respect to, because we can and we will be taking the derivative not only with respect to x, but with respect to y. So it's very, very important that you know this is saying, hey, we're taking the derivative, okay? And just one more thing while I'm at it, I just figure I'll throw it in. When I had started talking about this, we started saying about the first derivative. So f prime of x is saying we're taking the first derivative, whereas f double prime of x, we're taking a second derivative, and so on. Once we get to the fourth derivative, we just do something like this, okay? Or fifth or sixth. Usually we only talk about the first and second derivatives here. So don't worry about anything beyond that. Okay, so if there's something you didn't get in the last slide, make sure you pause the video and make sure you write it down so that you help yourself memorize it and it's part of your notes. So we have some more notes, and I usually take one slide at a time, but I kind of put this together because I think that it helps explain why we use the graphs of f for f prime or the graph of f prime to help us with the graph of f. Okay. So I have an example here for f of x. Usually when we're given the graph of f, they're not telling us what the actual function is. So I'm just going to sketch it out so that you have the idea that you're usually just given the graph and not the equation. Okay, so you may be given something like this. We see the graph of f. We see where there are zeros. Actually, it's supposed to be a zero at the origin. And we see where we have like mins and maxes. So this is f, and we can use it to graph f prime, or vice versa. So let's just do one way, and then maybe you'd understand, so we can talk about the other way. All right, so we must estimate the slope of the graph at f at enough points to assure a smooth curve for f prime. So you basically are trying to imagine where your tangent lines are drawn in. So if you were to draw in tangent lines to this graph, you can see how they're positive and they become steeper. And then this would be where we'd have a tangent line for about this point here. And its tangent line is 0. So think about that. Okay, my x, maybe -3, is a positive slope. And maybe at -2, same thing. But at about that point, -1.786, we have a slope of 0. Okay? So then try to figure out what would happen next. Hopefully you could kind of see how our slopes of our tangent lines, if I were to be able to draw them in, are negative. So it'd be a negative slope. Even when it's 0, it'd be a negative slope. That's supposed to be an m. And when it was about 1.120, again we have a slope of 0. If we were to draw in a tangent line, it would go straight across. So a horizontal line has a slope of 0, okay, and that's what's happening to our tangent line. And then let's keep going just for a tiny bit. So when x is 2, we would have this positive slope here. And so that's what we can see from the graph of f, okay? So what does that mean in summary? Because this is very important, okay? It's basically what we're outlining here. So at the points where f has a slope of 0, f prime has x-intercepts, okay? And we're talking about like the slope of the tangent line when we say slope. So the reason why f prime, okay, the graph of f prime would have x-intercepts is because that's where y is 0, okay? So now we know where we have x-intercepts. Now let's look at all our positive slopes. When we have positive slopes like we do here, that means our function is increasing, okay? So, and that's the case. Every time it was increasing, we were drawing in tangent lines with positive slopes. So the answer for y is positive when your function's increasing. Okay, that means that it has to fall above the x-axis because that's where your y values are positive. So let's talk about when your y values are negative. So let's talk about when y had a negative slope. That was where our function was decreasing because we're drawing in all of these tangent lines that were all negative. Okay, so when f is decreasing, the derivative is negative. So when we have to graph f prime, we have an idea that our y values need to be negative. That means that our graph has to be below the x-axis. So let's try to draw a graph for f prime. Okay, so I left this boxed information up because it's super important if you haven't already figured that out. It helps you when you have to graph f prime because we took all the information that we got from f, such as we have zeros at about 1, or I should say negative 1.786. It's a 0. And at about 1 point, what was that supposed to be? 120. I kind of wrote the decimal place in the wrong spot. Okay, so those are our zeros. All right, our y values have to be positive before our negative 1.786, because that's what's going on here. Okay, so our y values are positive up above the x-axis. So we put a dotted or dashed line or curve there. Between our negative 1.786 and 1.120, our slopes were negative. So that means our y values are negative. I'm going to, again, put in a curve dotted or dashed here to my point. And then when when x was 2, our slope was positive. So y has to be positive. Our positive y values are above the x-axis. So believe it or not, we're kind of creating a parabolic shape here, and that is correct. This would be a sketch of f prime. Okay? So now that I labeled that, we can actually take f prime and reverse this information to give us the graph of f as well. Okay, we just have to understand the summary that we have here in our outline that you copied in your notes. Okay, so I see x-intercepts. That means that I have horizontal tangents. Okay, either a min or a max. So these are where we have mins or maxes. So we call that relative extrema. And before the negative 1.786, since our y values are positive, that means that our function was increasing prior to that point. Our function was decreasing because it was below the x-axis between our negative 1.786 to 1.120. And then our function was positive again, so it was increasing. Where it changes from increasing to decreasing, okay, then we have a max, so now we know it's a relative max. And where it changes from decreasing to increasing, we had a relative min. So we know everything to kind of reverse our graph. And then we get f again. Okay, so it's not going to be as detailed as it was before, but we still have information about our graph. So f was increasing here, decreasing, and then increasing. And that's essentially what we had for f. So that's a relationship between our graphs. So practice, study, and we'll do more about derivatives after this.